So why Kubernetes? From my perspective, at least, it's really about efficiency and waste elimination, right? So why efficiency and waste elimination? We can look to where Kubernetes got its start, right? I don't know how many of you know this. The thing on the left, the cube on the left, is the Borg. So for those of you who are Star Trek fans, and I'm assuming that a lot of you are, you may realize the Borg was just this system that continually connected and absorbed other technologies, be those part of the cube and or distributed. So the Borg was the code name for a system at Google that they use to manage hundreds of thousands, if not millions of nodes. And the reason it exists is it ran, all their applications ran on top of this. It made it really easy for them to scale out dynamically, and made it very easy for developers to release solutions. Kubernetes emerged from that. You can almost say Kubernetes is the open source instantiation and improvement of that for the world. So when I say efficiency, the idea is that you can run on distributed environments broadly with any sort of compute underneath. And this is really a big change, particularly now that it's kind of commoditized with Kubernetes. And when I say waste elimination, I'll get into that more, but that has to do with software development. With what's happened with Kubernetes, it's made some changes in terms of roles, responsibilities, and rapidity. So we'll go into that. So anyways, why Kubernetes? I really see it as a macro change in terms of the efficiency of software development in particular and waste elimination. So let's talk about what's different here. So what is Kubernetes really? You can consider it a distributed systems toolbox. It's not the only one. There are other ones out there, but this is really created an API for distributed systems. And I think this is what makes it very, very different. It's an API for distributed systems for the purpose of making it easy to deploy and maintain applications. And what's different is that the primitives that are part of Kubernetes are very different than the primitives you would see in the standard data center or even cloud infrastructure. We're dealing with a whole new set of declarative objects, ephemeral objects, and that are really oriented towards application, again, deployment, making it very, very easy for that. And so what's happening is that it's a distributed infrastructure with a whole new set of primitives and an API, and it's really shifting the idea of infrastructure left. We talk a lot about shift left in security, trying to get early in the development process, what have you. I want you to kind of take that same framework and think about the fact that we're shifting infrastructure. It's infrastructure as code, but now on steroids. We're shifting a lot of that power left into development. And when you do that, when you shift all that power and responsibility left, it makes a change in roles. We're seeing changes you're probably all aware of. Obviously, DevOps has been around for, gosh, a decade. You're seeing things like site reliability engineering as well, and other, even DevSecOps, I suppose, that's more of a practice. But what this means for security is that roles and responsibilities are changing for security as well. And I would actually argue that the responsibilities for security are shifting left more towards development. Accountabilities or governance is even more so perhaps with security, but it's really shifting things in a way that I think is really, really important. And if it's something that you're unfamiliar with, I'm going to encourage you to become familiar with this because it's going to make your job different. If not already, it's coming to a theater near you soon. So what's the same though? The same is that you move from data center, right, to cloud, to Kubernetes and cloud native development. We still have bad guys. And the reality is that Kubernetes, because of its scale, again, think back to Borg, what Borg did for scale for Google, then Kubernetes releasing more of that kind of ease of distributed computing to the world. It makes it really easy to expose a lot more value to more people through more channels at higher velocity. So I want to think about two things here, why this is really important. For one thing, I think most people who are running Kubernetes likely are having it run in, be it Amazon, be it Azure, right? Google AKS, EKS, JKE. Some might be managing it themselves. So you still have a shared responsibility model. I mean, a lot of the underlying infrastructure, the nodes and whatnot, is being managed by your cloud providers. But what Kubernetes is allowing you to do is to be able to do distributed compute across providers much more easily. to spin up services much more easily with a lot more volume. And so from an application perspective, while the shared responsibility might not be as deep from a stack perspective, I'd say it's exponentially wider, and particularly wider in the place where it interfaces with the world, right? So the area that's actually exposed to people has the potential and or is exponentially much larger. So while the roles and what I'd really say the responsibilities for security in many ways are shifting left, the reality is that risk is still there. I'd say in some ways it's more inflamed, and in some ways it's less inflamed, right? Kubernetes changes things. It gives us some expressivity and power that we may not have had before. But the reality is what's changed again is that you have a distributed API for distributed computing that allows for a lot more velocity. What stays the same is the fact is that we have a lot and always have a lot more bad guys. All right, so what is winning now for us in this sort of environment? How am I looking at this? If you're a CISO in a cloud native company, a company that is working with Kubernetes, your company's probably done it because you want to move from, let's say, 100 releases a year to 1,000 releases to 10,000 releases with largely the same amount of resources, right? You want to get exponential scale. And one of the ways that you're getting exponential scale is really allowing developers in particular to retain their autonomy and agency. This is very important. I mean, again, you heard me talk about the idea that things are shifting left from an infrastructure perspective. The reality is the freedom and responsibility model is shifting much more towards developers so that they can expose more value to more people through more channels. From a security perspective, whatever that we're going to do from a security perspective should be participating in that autonomy and agency. So I'll give you an example that I've used. I've even written on it recently. If you think about NASCAR, right? You think about the fact that drivers are going really fast. They're going bumper to bumper, in excess of 200 miles an hour. And they have a pit crew. And if you've ever watched NASCAR, you've seen how these pit crews, they're all seemingly very athletic, move very fast. And I liken DevOps and SRE to the pit crew. They go in and they do everything really fast and they get out of the way. They clear the way of problems and they get out of the way. And the reality is DevOps and SRE, they're really developers supporting developers, but they're very clear in their mission. The mission is really about velocity. The mission is about winning, ideally in one piece, right? We don't want anyone getting hurt. When we look at security, we don't necessarily observe them as part of the pit crew, right? We don't see them necessarily supporting the developer's autonomy and agency in terms of winning. Again, what's winning for business? Exposing more value to more people through more channels, do more business. So I think it's really important that if you're going to be participating in cloud native development, that's ideally and probably likely having Kubernetes under the scenes, whatever you're going to be doing in terms of a program design as a leader, in terms of the capabilities, you really need to be working backwards from this concept of enhancing developer autonomy and agency. I'm going to say from experience that if you don't operate from that perspective, it's going to be very tough sledding for you from a career perspective and for your teams to be successful. So going further down this path, we're working in a hyper compressed times, and Kubernetes helps all that much more with making things go fast. And the expectation really is immediacy of satisfaction. And what do I mean by that for a developer? The reality is that as a developer, my ability to go from my laptop right into production, I mean, developers can, they can create ingresses now, right? I define an ingress. The idea is I'm creating something that in theory could be reachable from the outside universe. That power and that expressivity and power to do that is now with the developer. And plus, again, they're going from 100 to 1,000 to tens of thousands of releases. So there's already this motion of immediacy of satisfaction in terms of getting their work done, right? I would argue that anything that we're going to do from a security perspective really needs to be received in the same way. You're preserving their autonomy and agency, and you're thinking about anything that you're going to do that may have some impact on them in any way, shape, or form should be received in terms of immediacy of satisfaction. Hopefully that makes sense. Another principle that I think is really important, and for those of you who have read my book or heard my talks, I talk about, don't beat the bear, right? Or what we call beating the competing model. And this is going to tie into the thing I'm going to talk about next. As you're designing capabilities, as you're looking to participate in becoming part of that pit crew, as you're looking to become part of developers helping developers, as you're looking to become part of that team that's oriented towards helping your business win. The idea is you don't have to aim for perfection. Listen, DevOps has been doing this for at least 10 years, right? They have a big jump on you. I mean, you're completely outgunned when it comes to comparing yourself to development. Your job is to move the needle in the right direction, right? So when I say these things and you think about Kubernetes and being overwhelmed with technology and, what do I do? Which way is north? Just focus on the fact that, you're not competing with perfection. Again, you may have heard the joke, right? Beat the bear. Two campers are going out camping. One of them puts on running shoes. The other one has hiking boots on. The one with hiking boots says the one with running shoes, why are you wearing running shoes? And the one with the tennis shoes says, well, I've heard there are bears out here. And one with the hiking boots says, well, you are never going to outrun a bear. And the response from the tennis shoe one is, no, but I'm going to outrun you, right? And so this is, again, the idea is that, look, we're not competing with perfection. We're trying to compete with the competing model. And if the competing model for security is saying no, that's already a model that's pretty easy to beat. You want to move from that to moving into how you help support autonomy and agency of developers, allowing them to take more responsibility for security. Again, when you're dealing with high velocity software development and you're totally outgunned 100 to 1, 200 to 1 developers to security folks, and you're inserting yourself in the middle of that flow, and you're going to be the arbiter of work that gets done, particularly security work, I'm going to argue that you are offending autonomy, agency, and certainly immediacy of satisfaction. And you're in a losing position. That's different than having governance for a system. That's a different situation. But when you're putting yourself in the middle and being an arbiter of how work flows, you're already in the wrong place. So we want to get ourselves out of that, get ourselves into the pit crew, and focus on winning. One step at a time, beat the bear. Don't beat the bear, beat the competing model, which oftentimes is no, or doing nothing. So with that, with those principles in mind, talking about what Kubernetes is, it's a volumetric change in the development of software. It shifts roles and responsibilities left to the developer, right? It's distributed application-oriented infrastructure that puts them in the seat of control. We want to move security out of the responsibility game and enhance freedom and responsibility for the developer to do the right things. But we still have an accountability for a whole system in terms of security. You may have, you may be in an environment where you're dealing with hundreds of clusters, right? Thousands, if not tens of thousands of nodes, 100,000, 200,000 releases a year, or maybe it's less. You don't want to be in the middle of that. You don't want your small little tiny little team to be in the middle and being the arbiter of every little thing that gets done or not. Your job is to have an overarching view of the system, and particularly any critical risks that pop up. So I'm going to share with you a framework it's evolving right now, I suppose, that started with my first book, right? My first book came out, gosh, I guess 4 or 5 years ago. And because of that, I started getting pulled into what I call CISO speed dating. A third party decided to shell me out for consulting engagements. Most of them were an hour long on what you'd call, I suppose, data science, quantitative risk, predictive analytics, what have you. Mostly with Fortune level CISOs and their teams. So I've done over the past few years, probably about 200 of those. And most of them, by the way, are going through digital transformation of one form or another. But all the talks are about, hey, how do I go about measuring what I'm doing? In particular, how do I deal with software development? How do I measure, understand, improve, optimize without getting in the way? So this methodology is really a distillation, really, of talking to a lot of CISOs and the toil that they're dealing with in their teams, and understanding the questions that they have, and trying to come up with a satisfying set of real measurement primitives that would help them, particularly for those who are dealing with what I call more DevSecOps activities. So let me walk through this for you really quick. So this is a framework for measurement, right? And it's really oriented towards optimization. This framework has what I'd call 6 primitives in it. The first one is basic counts. Listen, you need to count stuff, right? You can call it a metric if you like, but the reality is you're gonna count things. A lot of things that we count in security, by the way, are hits and misses. A lot of security is hits and misses. A lot of life is hits and misses. And in fact, a lot of the statistical practices and probability really boil down to on and offs, hits and misses, right? So the framework has a lot of that to begin with. You can call it the most atomic sort of primitive in this framework. The next thing in this framework is burn down rates. The reality is in security, listen, your systems, your tools, your people, your third parties, they're going to find things, right? And guess what? With the explosion of first-party software that's going to happen with Kubernetes, or is happening for you, you're going to have a volumetric explosion in risk potentially. So there's going to be stuff that's happening on a day-by-day basis that's going to be piling on, new things that come in and new things that pop off, right? You want to have a way to measure the efficiency with which risk that's been discovered, that's been acknowledged, that's actually real, is getting burnt down. This is one measure. It's not the only measure. It's one of several measures. By the way, burn down is on top, you have the things that are removed, right? Risk that's remediated or removed or mitigated. And the bottom is risk that's been added. So in month one, you might have 100 things that come on and 50 things that pop off, right? So you have a ratio. And maybe you're running, maybe it's critical, it's critical, externally, exploitable vulnerabilities, blah, 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 whatever it is, however you distinguish it, you might have, that might be a part of the real estate that you want to measure. And you would find yourself, you'd baseline, you say, okay, we're running at a 65% efficiency rate. And that could be, again, you could look at that across the last month, or you can have cumulative for a whole year, a cumulative rate. And then you can actually say, well, okay, based on that cumulative rate where we are now, what's the trend versus the previous month? You could have a delta with this. But it's a way for you to start understanding, are you getting better or are you getting worse at controlling risk, particularly the risk that you've acknowledged? I don't think this is necessarily particularly enlightening to many of you. You may already do this. By the way, it's a standard sort of agile metric out of software development. So we're really taking from them and applying it here. And we want to do that, by the way, because if that's the way they measure and we're looking to be part of the pit crew that supports them, we probably want to start using some measurement methodologies that would make sense to them. So basic counts, which are part of the composable things that go into burn down rates. The next one is arrival and departure rates. So there's a standard way of measuring, I'm not going to get too statistical with you. Many of you probably heard of the Poisson distribution. There's a bunch of variants along that. The idea is that you're measuring the rate with which things materialize. So you could say the rate with which critical vulnerabilities materialize on our external infrastructure. Let's say you've chosen to decompose and do that. You could say that our current monthly rate, again, if we're using statistical approaches, there'd be variance and all that, but let's just say it's 40, right? That's 40, that's the average rate over the last month, and there'd be a delta from the previous month or previous quarter. The idea is you want to get an idea with the rate at which things materialize that matter, right? That's going to create work for somebody, by the way. You also want to understand the rate with which things depart. You want both of those. You want to understand. So again, we have basic counts, which these things are made of. They're empirical, mathematically unambiguous, and audible ons and offs or hits and misses. They're not squishy things. They're very empirical. You have burn down rates. This is the work that we're doing. We want to understand how much, what's the rate at which we're actually handling this risk. And we want to understand the rates with which things materialize and with which the rate they disappear, right? So here's another one. These are, again, the fundamental primitives for measuring what I'd call DevSecOps capabilities and orienting yourselves towards more performance. The next one is, you can call it survival analysis. It's also known as engineering failure analysis or time to live. By the way, the framework starts with what I'd call simple arithmetic approaches, right? Deterministic approaches, and then shows you how to do all the probabilistic stuff. For those of you who are very nerdy, it tends to be very Bayesian in nature. So survival analysis is a way to understand really time to live on a curve. And this really comes from epidemiological sort of stuff. So obviously a very timely sort of subject right now in the time of COVID, but it's a way to understand risk and how it ages, and to understand how even what do you call tail risk ages. So let me give you an example. You might say that 50% of our critical, remotely exploitable vulnerabilities live for 48 hours or longer, based on today, right? The data cumulative up now, 48 hours or longer. 10% lives for 2 weeks or longer, and 1% lives for 400 days or longer. So you end up having a curve, right? And again, when you get into probabilistic methods, we take into consideration our uncertainty. The idea is you understand a curve, and then you can understand how well that curve is doing over time. You could have an improvement kind of in the mean, like at that 50% rate, but it could be getting worse on the tail, that 1% rate. And listen, bad guys tend to, people attack the back of the herd. You want to be aware of that. So it's really important to have that and be able to have systems that allow you to alert on those things and if there's changes, whatnot. So again, basic counts make up everything: empirical, mathematically unambiguous, auditable, burn down rates in terms of the work that you actually brought on, right? Typically would manifest as some sort of ticket, whatnot. Arrival rates of risks that shows up, you can see threats or vulns, doesn't matter. Arrival rates and departure rates. Because again, you're trying to base, again, all these are, by the way, are about baselining your capability, right? Capabilities are composed of people, process, technology, tends to be very complex, but we're looking at the empirical evidence, the outcomes that complex capabilities produce, right? So survival analysis, okay? Lastly is escape rates. You can Google escape rates. You'll see some DevOps talk about escape rates. There's discussions of escape rates in healthcare. Escape rates actually it's actually a pretty simple concept. You can get complex in implementation. I'll try to simplify it for you now. So what is an escape rate? Just think of a bad guy, escaping from prison, or dangerous, homicidal maniac escaping from an asylum. The idea, there's a rate at which risk moves from a state of control to a state of less control. So for example, you could have vulnerabilities that are discovered in stage or pre-production. They're discovered, they're known. Your tools, your goodies, maybe they're integrated into your CICD. I don't know. But there's risk that's been acknowledged. It's observed. We see it. And then there's risk that makes its way into production. We observe and we see it, right? Now, if we see something that we observed in pre-production, but then we observe it in production, that's something that escaped. There's a variety of ways to look at escapes: north-south, east-west sort of risk movement, whatnot. But the reality is we always want to go back to empirical, mathematically unambiguous, and auditable. I'm going to go back to this thing, auditable. It's really important. At some point in time, you're going to get audited on this stuff, particularly if you're making some decisions, and you need to make sure that you can point back to real hard data. So not that I'm going to say that this is perfect, what I've put together here, but when it comes to what I've seen as a cloud native CISO and talking to several hundred CISOs and their teams, in dealing with the quantitative nature of the books that I've written, this seems to me to be some of the fundamental things that we can do, particularly when it comes to DevSecOps oriented measurements. I would say that these are the types of measurement primitives that you can use to make betterments. So I want to talk about one more thing real quick. We've talked about baseline objectives. So these end up being baselines. You're baselining processes by looking at outcomes. We're looking at empirical outcomes, and we're baselining rates to get an idea of and how they change over time. Now, objectives is the idea of being super clear about the outcome of measurement. Like, what the heck am I talking about? What is it that I want to measure, and why? This ends up being a little more qualitative in discussion, but I'll give you a couple quotes, or one quote, and then I'll give you an example of why this is so incredibly important. So I think is it Francis Kettering? It was Kettering. No, it's Kettering. A problem that's well-defined is a problem that's half solved, right? I think in security, we can end up measuring a lot of things that we think are important, because we see vulnerabilities piling up. That must be important. Or we see angry packets going across the network. That must be important. I'm not saying it's not, and very well may be, but you need to be aware of the fact that we as humans have a tendency to want to measure the things that are obvious, and oftentimes forget to measure the things that are important. And it may be difficult to get at what's important, but I think through a lot of discussion, through being real clear, we can get to there pretty quickly. But this shows up really obviously. You're probably aware of the story. It was World War II. Bombers were, I think, roughly 5% of the bombers were getting shot down by artillery. And they decided, a bunch of officers decided that they wanted to put additional armoring on these bombers. And they looked at bombers that had returned from battle. They looked at where the holes were on the planes, and they went about starting to put additional armor on the planes. By the way, it reduces the aerodynamic nature of the bombers, creates more fuel, very expensive. During the process, there was a statistician, Wald, who said, look, I have a feeling that it's the bombers that didn't make it back that have holes in different places. And he was right. This is a standard sort of problem that we have, where it's very easy and compelling to measure the things that seem obvious, that seem dramatic. The idea of having clear objectives, and the Boom framework helps you to walk through that. How do I go about getting a standard set of clear objectives? Then how do I start baselining those processes? And by the way, I'd say 90% of what you need to do to improve processes will just occur right there. But the next step is then to get into optimizations, right? How do I then, having these baselines, understanding an objective that I'm looking for, how do I go about making sure that the things I'm going to invest in, the knobs I'm going to turn to make betterments, that I'm actually choosing the right ones, and I'm not choosing things that are a distraction. So that's baselines, objectives, and optimization. The measurement just refers to the fact that we use both deterministic and probabilistic approaches. And the probabilistic approaches are really predictive analytics or Bayesian analytics. I shield you a lot from a lot of that complexity. So that's the model. So I'm going to dive into escape rates real quick, just to give you an example of escape rates. So let's assume that you are a CISO, you're with a moderately successful company that has a lot of, maybe hundreds of software developers, right? A bunch of different small two-pizza teams, Scrum teams. And you're going to go ahead and measure critical vulnerabilities that are getting exposed externally, right? So you're going to measure that. So on the left-hand side, you have stage. And let's assume that you have some semblance of vulnerability management. Maybe you have some tooling, I don't know what you have, but you have some way to detect whether or not there are vulnerabilities before production. And then you have some way to determine whether vulnerabilities still exist after production. So on the left, we see the green ones are vulnerabilities that are known and remediated that made it to production. The left are red ones that are known and not remediated. So you have an escape rate there. You have two things that escape. There are unknown things that happen all the time. That's all the stuff that we don't know. Let's get good at the things that we do know, and then we can start talking about fantasy, right? So we're dealing with real hardcore, audible, empirical, mathematically unambiguous evidence here. And so this is a small amount of data. And to say that, okay, well, that's just the exact, that's the exact escape rate would be wrong. Because again, the reality is that we don't know how many vulnerabilities there are. We're unsure. We want to baseline a process. So in this case, by the way, I'm showing you a little picture into more advanced measurement. So this is the predictive analytics. I use this with air quotes. The reality is this is called empirical Bayes. These are all fancy words. We like to, I guess statisticians like to put intellectual prophylactics around their things to keep the pagans out like myself. So we have a 25% escape rate with a lot of uncertainty. We're actually pretty unclear about what the actual rate is. So we go cumulative to the next month. This is cumulative. And we have more escapes, stuff we know about that gets into production. And we're starting to baseline. It looks like actually if we're to make a bet, it's closer to 30% now. But we have more data, and with more data, your uncertainty shrinks. 1 second. So we go one more month, cumulative for a quarter. This is just one Scrum team, right? And we're starting to baseline. We're starting to see that this rate is starting to stabilize, roughly around a 19%. There's some variance. We don't have all the data, right? But as we get more data, it'll get pointier and taller, and we'll know more, right? So let's look at what this might look like to instrument this a little bit more. You don't need to understand the code that's there. All you need to know is that I wrote it, but please don't be impressed. This is R, by the way, go R. So what we have here is we have the understanding of critical vulnerabilities in this case, right? We can call these P0 vulnerabilities. You could say you have an SLA around P0s are supposed to be fixed in 24 hours, right? But the idea is that you want to know about any of those that tend to go above a 5% rate. Let's say you've baselined right now and your KPI is around 5%. You can measure that. You can have P1s and P2s, and the chart below it represents that data, right? So the colors correlate with that. The idea is you're trying to get at, where do I have P0s that are having a tendency to exceed what I've defined as an acceptable baseline rate, which is 5% in this case for P0s, a 10% for P1s, or 20% for B2. So why is this important? Because you may have Scrum teams that just started out. You may be a very successful company. You're hiring people all the time. You're hiring third parties, and you're just growing like gangbusters. You're using Kubernetes, and you're excreting a ton of software. So how do we go about addressing that? So again, escape rate is a DevOps metric, by the way, and we use rate. We start using rate as a policy to be. We're setting a capability, we baseline. We can score the strength, by the way, of relationship between capabilities and rates. This gets into optimization. And again, optimization, the practice of optimization is doubling down on relationships that matter. What we're really doing is we're looking at the kinds of data generating processes. We're trying to understand those that seem to have to make the most difference. And by the way, we're trying to stop doing those things that aren't important. Right? We have something that we're doing and it's actually not having an impact, let's say, of getting to 5%. Well, we should probably stop doing that. So let's take a look at this a little further. We're going to go at a little scale here. So let's say you have 50 Scrum teams. My first cloud native gig, we had I think 150, but it's much bigger. So what are we looking at here? This is kind of an eye chart. Just know that that's 50 Scrum teams. Some of them are brand new. And how do we know they're brand new? They look like very wide TIE fighters. You think about Star Wars there. That means they have very little data. It means we have a lot of uncertainty. The one on the very bottom has been around for quite some time. So let's get this a little bigger so we can look at it. So again, let's look at that first one up top, the number 30, that's team number 34. They've had a total of 140 escapes over 700 events, right? So we see where they are. We look at the next one down, team 50, less data, right? 100 total, then you go 50 total. So the reality is that we have some teams that have been around for a long time. We have a lot of data. We have teams that have not been around very long. So what are we doing here that's actually particularly interesting and useful? Well, I would argue that most people, when it comes to security measurement, if they were to have a new team, they would say, okay, well, we know nothing. It could be, they could be creating critical vulnerabilities all the time, or they could be creating them none of the time. But the reality is we don't treat any other thing that way. Think about baseball. We usually assume that people have a batting average somewhere around, 220 now, 230, whatever the batting average is. And if you're a new batter and people are going to be making bets on you, you're going to inherit that batting average in general. And then as you have hits and misses at bats, they're going to start changing your rate. That's the same thing here. So what happens here across all 50 Scrum teams, they have an inherited average, which goes into the calculations. And then as we learn from the data, as there are more hits and misses, it adjusts. The red line represents that current average for all of them right now in time. The blue line would represent the next goal. We want to start shifting left. We're going to start investing in certain capabilities to actually make us better. And the green one could be, okay, and then 2 years from now, that's going to be the new average we're going to shoot for. So again, a Scrum team is like a baseball player. They can inherit a league average, right? We don't just start with tabula rasa. We start with a league average. The more data we have, obviously, the more certainty. Again, on the chart on the right, the teams that are very wide, those are new teams. We don't have a lot of data. The teams that are very squished together, like the one on the very bottom, we actually have a lot of data. The true vulnerability rate is likely to be 95% within each band. This is a credible interval, not a confidence interval. So a little bit different. But what we'd say is we believe, based on the amount of data we have, that the true rate exists in that band, again, the edges of the TIE fighter, right? And we can set KPIs, which can be points, just like the color line. So we say, all right, we are going to be shifting over time. We're looking to get better through maybe new security practices, things that we might do to improve our environment. And we want to be able to shift that average performance over to the left. All right, so I've shared a lot with you. I've talked about the nature of Kubernetes, right? What does Kubernetes do? It allows us to expose more value to more people through more channels with a tremendous amount of velocity, right? Google was doing it with this thing called Borg, eventually shift to Kubernetes. Everyone has Kubernetes. I'd argue that Kubernetes is kind of at the source of cloud native development, and it's about going from 100 to 1,000 to 10,000 releases with the same amount of resources. I'd argue that much of digital transformation finds its root in this activity, all right? We talked about what that is, right? And then we started eventually moving into how we might go about measuring in a high volume environment, right? Looking at what I'd really call DevSecOps metrics. I talked about a framework that I've put together for this, which I'm publishing right now, which will be available to you. It should be out on the Soluble blog shortly, and it'll be in my book, right? By the way, for those of you who are thinking of writing books, you never make money at books. So if you think I'm trying to sell a book, I'm certainly not doing it for money, because I don't make any. So no shameless showing there. So I want you to consider that Kubernetes exists to enable developer autonomy and agency. That's a different way to think about it. Kubernetes exists to enable developer autonomy and agency. It shifts application infrastructure left in many ways. It supports freedom and responsibility. You need to win by enabling development teams to do the same with security. To the extent that we stand in the middle of the torrent of software and are going to be the arbiters of security workflow, and are going to be the arbiters of what's good, bad, and indifferent, is to the extent that we are disenabling autonomy and agency. Consider that Kubernetes shifts infrastructure left with new primitives and APIs. So you win by considering you are now totally outgunned. You were outgunned before. You are outgunned in terms of both the volumetric rate change in software, and you're outgunned because you have a whole new set of primitives that probably a lot of your teams and your tooling don't understand, right? You get leverage, though. You're going to get leverage, though, by clearing security obstacles out of the way and then getting yourself out of the way, too. What do I mean? Again, going back to that analogy of the pit crew, become part of that pit crew right alongside DevOps, right alongside SRE. Be a part of developers, helping developers. So consider that Kubernetes shifts many security responsibilities to development teams. It's just a reality. You're probably likely not going to have access to clusters. They are. SRE will, DevOps will, you won't, developers will, right? It just shifts all the, and in fact, a lot of that infrastructure is shifting left so much that's disintermediating a lot of ops jobs too, right? So it's not just you, it's operations in general. And so it shifts that and increases the need for effective security, accountability, and governance. I'm going to argue that your role, now that risk is being scaled out, right? Exposure risk is being scaled out in ways we've not seen before. What it does change is the need for better accountability and governance. I'm not talking about compliance. I'm really talking about, well, honestly, measurement in many ways. So consider that ultimately, Kubernetes enables the business to capture more value faster. That's what the business, that's why they're doubling down on this. That's what they want. You win by considering security as a value-added solution that unblocks risks intolerant, revenue-generating customers. I think that's really, really important from a security perspective. Part of the thing that we need to really get into is that if you're working with listen, if you're a CISO and you've been hired, you're probably working for a successful company. They don't hire folks like us unless they're getting to a place where they're dealing with serious, large customers who are saying hell no to their businesses unless they can demonstrate some semblance of hygiene, right? That's revenue that's being blocked. Your job, I would argue, is to start getting proactive about how do I unblock that revenue in a way that doesn't block our development teams in the process. So that's really it in terms of my presentation. I said in the beginning now for something completely different, quoting John Cleese, so I know it's a little bit different. If you're interested in learning more about the Boom security framework, I have an article coming out likely tomorrow. It was supposed to be out today, but my editor beat me up. And so that'll be coming out. The first one of several will be coming out tomorrow. It's free. You don't have to go and sign anything. You just go get it. It's there. I'm sure I'll be tweeting and posting it on LinkedIn. And my book, which has been a slow roll, is coming out very, very soon. Advice, again, to entrepreneurs and you authors out there, don't sign a book deal with a forward or an advance when you start a new venture capital backed company. Try to line those things up so they're not overlapping. But that being said, I know that this got a little technical in a little bit of a different direction. I know they got a little philosophical too, in perhaps a little bit of a different direction as well. This is just, really from my experience, again, as a cloud native CISO, and my experience talking to hundreds of cloud native CISOs, particularly those who are struggling with Kubernetes in cloud native and how to measure. So again, I thank you for your time, and I'm very open to taking questions if I haven't scared you all off.
Excellent. Rich, thank you so much. That was really an awesome presentation. Greatly appreciated. And of course, we do have questions. And typically I would roll with, my question right off the bat, but instead I've got Brooke Schoenfeld here, who has not joined us in a long, long time, and he's got some questions. And we've known each other a number of years, so I'm going to start with a couple of questions from Brooke. And the first one is, give us some examples of how software security practices might be shifted to organically integrate with, say, a DevOps chain.
Say that again?
Give us some examples of how software security practices might be shifted to organically integrate with, say, a DevOps chain.
Okay. I think what they probably mean is maybe integrated into CICD. This is what I'm thinking they're talking about, how you might integrate software into continuous integration and continuous deployment.
Yep.
Let me start with how you wouldn't do it. How you wouldn't do it is doing it in such a way where the flow of software, in terms of going from developer writing code to actually deploy, where that flow is having to wait for scans to complete. That's how you would not do it, right? So if you're doing any sort of process that's going to block the actual the ability to accelerate and develop software, I'm going to argue that that is not how you would want to do it. But how would you want to do it? I would argue that whatever it is that you do, that from a tooling perspective, it has to be the kind of thing that won't smell to them. It has to be the kind of thing where typically, since they're going to be implementing it, right? You're not, again, you don't have kubectl. You're not logging into things. You're probably not, again, if you're with a successful company with their separation of duties, clearly you're not doing that, right? So it has to be the kind of thing where it would make sense to them. It would be something likely that is germane in terms of how they go about doing work. If we observe how DevOps acquires solutions and deploys solutions, DevOps SRE, typically it's going, largely, if it's not open source, they're getting it from, AWS or Google, right? And or it's some other SaaS related solution, definitely API based, non-blocking. And typically it's going to have next to zero overhead in terms of, because again, they're not actually particularly interested in security, to be honest. I mean, they want to make good stuff, don't get me wrong, but they're not interested in the care and feeding of security solutions. So I'll just reiterate, how do we know what not to do? If what you're deploying is going to have an actual impact, meaning making people wait, and going back to the principles of waiting, he's like, no waiting. That's waste. That's economic waste, by the way. If you're going to create economic waste, it's just not going to happen. It has to be the sort of thing from an affordance perspective, right? That makes sense to them, right? And if we look at how they actually consume third-party software or open source, it has to line up with that sort of activity. So hopefully I answered the question. Again, realize I'm a CISO, but this is what I've observed.
Got it. And just for fun, because I'm sure Brooke is still online, and he's got one more question. So this one is also, since there's a fair body of data that demonstrates both that only a small percentage of discovered vulnerabilities actually get exercised and that SV-ISSA isn't a good predictor of exercise, how might developers identify those vulnerabilities in that might get exercised out of the torrent of announcements?
Yeah, so I think that, again, back to what I said about security being the arbiter of what's important and what's not, like the idea I'm going to stand in the middle of the torrent of software and say, yep, that's a false positive, that's a false negative. I'm sorry, you're probably not a Kubernetes expert. You're not. Most of you aren't. You're probably, whatever the vernacular of the language they're dealing with, you probably don't, you don't spend your day in, day out writing that language. You're not a service owner. You don't know what the purpose of that microservice or what it's doing. You don't know. You have next to zero context. Your job as a security person, going back to this idea of governance, if you're going to put solutions in place, is getting immediacy of satisfaction for that person who actually has to make change, the richest context humanly possible. So if it is a false negative, not false negative, it's going to be false positive. If it is a false positive, that's at least quickly ascertained by the experts. I know listen, I've got kind of a data science background myself. I've built teams. I'm a big believer in analytics. Obviously, I write on the topic. But the idea that you're going to somehow automate away the deep expertise that's embedded in creating services, and you're going to have a security magic wand that all of a sudden is going to vet through all this stuff and say, this is the thing. No, I think our job is actually to enhance operational excellence. Again, moving in terms of freedom and responsibility to them so that they can quickly, even in bulk, just swat away all the noise. This is my belief. Security does not have enough expertise to sit in the middle of various software languages and the Kubernetes Kubernetes system and be some arbiter of truth. It's not gonna happen for you. So stop.
I think that's pretty clear. Thank you. Next question. So this one, nice, pretty clear question coming from the audience is, what is a way to work with developers to guide them while staying out of their way, but keeping visibility of what they're actually doing?
Well, I suppose governance is what we're referring to here more broadly. You can call it visibility, right? And let's just start with that. Why does a security person want to have visibility, right? And we can drill into visibility to what, right? What is it that they're trying to see? You know, I would say, you know, how do we know what's important for the security team to know about? Well, let's look at things that CISOs get fired for. That's one thing too. You know, was there an ingress, or, you know, all this in a production environment, was there an ingress all of a sudden that showed up dynamically that actually is exposed externally, right? All of a sudden, oop, boom, there it is. Again, you're dealing with hundreds of two-pizza teams, maybe hundreds and hundreds and hundreds of developers. You're doing thousands or tens of thousands of releases a year, and all of a sudden, ingress shows up. This is the kind of thing that you would, as a security leader, are going to want to know about, particularly if it's something new that didn't happen before, and you're going to want to understand, you know, okay, is this a thing or is this not a thing? You probably are not going to have enough context in and of yourself to know the answer to that. So your job is to build capabilities together that allow the organization, particularly those who would be responsible, in theory, if you're tied into GitOps and whatnot, you'd have some idea of ownership, right? You've done correct labeling. You'd be able to quickly go to the actually responsible people and say, is this something, is this nothing, right? So, you know, how do we get visibility about the things that are really important? How do we get it in a way that's quick and meaningful to us? And if there's going to be work, how do we get that work to people, again, without us necessarily having to be, you know, necessarily a traffic cop? I only answered one part of your question. I don't know the rest of it. So if you want to repeat it, but I think I answered an important part of it.
Yeah, I think if we want to go further, we can argue about that later. But I have a question from Tyler Pinkard, and this question is, with respect to Kubernetes security, do you have strong opinion on container versus host security / both?
Container versus host security?
Yep.
Yeah, I mean, yes. If you have, you know, if you have container images that are out of date, they're packed chock full of software that is vulnerable and it's actually exposed to actual threat, be it external or otherwise, you shouldn't do that. If you have hosts that can then because someone can escape out of that container that's now vulnerable and they can get into the host and then go do a bunch of extra chaos, that's bad too. Don't do that. My recommendation, to the extent possible, is you can transfer as much of that risk to your infrastructure provider as possible, because let them own that, as much of that risk as humanly possible.
Okay, got another question for you. And this one is, I have developers doing different things in different cloud services. How can I work with them to apply security in a standardized way across clouds?
Multi-cloud, multi-cluster, how can you do that?
Yep.
Well, again, you know, give up on the idea that you're going to have people who speak the vernacular across all those variants of Kubernetes across clouds and whatnot, right? So you're going to need solutions that I suppose democratize the intelligence, right? That make it relatively easy to understand across clouds, across clusters. I think that's going to be really important. And, you know, and developers, really part of the thing is that we're trying to shield them from the implementation, right? They don't necessarily, they likely won't necessarily be experts either. So whatever it is that you put in place, you want to make sure that it gives them if they're the one who are going to be responsible for making a change, like all of a sudden it looks like I've deployed, you know, this is my SQL database, and I use the Darth Vader image from the Death Star, and I have, you know, I have, you know, clear text passwords in my, you know, config map or whatever. You want to just make it as easily as humanly possible to get that work to the right people in a way that's readily digestible by them, so they're not going on a hunt to get answers, but shield them from the complexities of the implementation, the multi-cloud, multi-cluster implementation. That'd be my best, very high level answer.
Sounds good. So I've got one more. How can I learn about our security posture with Kubernetes as developers are working? How can I collect data I need for compliance without visibility of what developers are doing in different cloud services?
How can you go about getting visibility into what developers are doing? I mean, it sounds like some of the same sort of questions. Well, you know, don't go ask your DevOps and SRE folks. They'll tell you, oh yeah, you just, you know, here, kubectl, go log in and go do this. Of course, if you're a successful company, they're not going to give you that. You're going to need solutions, again, that make it really easy for you to get real-time telemetry across your environments, that reduce the complexity, the multi-cloud, multi-cluster complexity for your security teams. And then as work is generated, again, the idea, we're trying to optimize capabilities. This is about work. Any work that may or may not flow to those developers, again, whatever it is that you're doing, you've got to, again, shield them from that complexity. There was a lot to that question, and kind of I wasn't entirely sure, but yeah.
Okay. Well, I think that looks like it from the questions from the crowd. And again, thank you so much for joining us. That was really an awesome presentation. At this point, I will hand the reins back to Ed Fry, our chapter president, and we'll take it from there.
Awesome. Thank you.